How's it going, everybody? And welcome to another edition of the YouTube Ask Me Anything. So we're going to answer a couple of questions and go from there. So I've been kicking around the idea, before I get into any of the questions actually, I've been kicking around the idea of, I mentioned in previous videos where I was going to create a website and basically, so I could have everything that I produce, whether it's videos, books, or the like, in one centralized location. And I'm still working on doing that, but I haven't found a good way to curate that. So what I am thinking about doing is leveraging Patreon, and because it's already starting to work out, there's a lot of you have bought the Enterprise Workbook through it, and it seems to be a consistent thing. So, and I've learned a little bit about how that works since then. So I'm probably going to start leveraging that more for all the stuff that I'm producing. So as more books get produced, the other thing is the taking all of the video courses that I would build for any of the technologies that I dive into, instead of making them freely available on YouTube and only getting a small view count for those that are actually interested. I think I'm going to switch gears on that, and I will probably end up using Patreon to do that. So it'll just be like a dedicated paid tier for that, if you guys are, for those of you that are interested in doing that. So still have to figure some of those things out, but that is the game plan. So instead of having a dedicated website, you would just click on the Patreon link and it would take you to where you want to go, and everything would be available to you. I'm still working on the details behind that, but soon. That is the plan. So with that being said, like I said in yesterday's video, I do plan on, I've already got a lab developed for the NRC workbook, so just a matter of going through and getting it all stood up and all that good stuff. There's not going to be any CSR 1000 Vs because I realize people have limited resources and things like that. So the intention is to have a sizable topology, and then we can work through the details. So, but that's in the works. So I will probably, once I have a decent amount of it done, or it's near complete, I'll have some people do some technical review on it and go from there. So the first question I wanted to get here is, if I create an interface VLAN 10 and give it an IP address and do the show interface description, which is what I think you meant to say here, I see the interface as up-down. Apparently, I have to create the VLAN 10. Can you explain why this happens? I find this a bit annoying, as interface VLAN 10 should not be related to VLAN 10, right? That's correct. They're two separate things. So if you're on a Cisco switch, a Cisco Catalyst switch specifically, and you do not create the VLAN first, then you're basically creating a SVI that is going to be a gateway for a VLAN that doesn't exist. So that's what ends up happening there. So if you don't create the broadcast domain, then the line protocol is going to be down. So the same thing would happen is if you were to not physically plug in a cable or an RJ45 Ethernet jack into a gig 0/1 on a router, and you were to do a no shut, it would be up down, which means there would be physical, the power would be enabled on the interface, but there's no, it's not sensing anything at the interface level, so it would be up down until you were to plug something in, then it would be up up. So the reason why is because there's no broadcast domain, there's no line protocol. So until you create the VLAN, and additionally, you can create the VLAN but not have any ports enabled on it. So creating the broadcast domain itself would still work. If you were to do a show interface description, you would still get it to come up, and it would show as probably still down. In order for a VLAN to really work, you need to have at least one port in it, and that it works the exact same way as it does on a physical interface. So until there's a port in it, it's going to show as up down. So the down is, do you have any ports inside of that VLAN, meaning that they're up. And then in addition to that, if you have a physical interface, gig 0/1 for example, on a router or a firewall, you're going to see an up down because the interface is enabled but there's nothing plugged into it. That's essentially where that comes into play. So, which is a little bit different, and so I find this point a bit annoying, as interface VLAN 10 should not be created, should not be related to VLAN 10. Well, right, they're two separate things. One is the broadcast domain, one is the gateway. So, the best advice I can give you for that one is simple. Don't ever create the SVI before you create the broadcast domain. That's how I always do it. Create the broadcast domain first, so VLAN 10, and then enable it on whatever port you need to, and then once that's been done, go ahead and create your SVI if you want to be able to get traffic in and out of VLAN 10. That's what I would do. So hopefully that answers that question. What's the point of sourcing a virtual interface at a ping test? In reality, it will have to come out of a physical port, so I don't know what's the point of that. Simple. Have you ever done a connection or tried to do a ping sourcing off of a port that the remote router doesn't know how to reach? If you have and it dies, there's a reason for that. So if you don't source it, and a lot of the workbooks that I've written, the workbook that I've written, as well as a lot of the testing that I do especially when I'm doing MPLS, what is the main thing you see me do? I always source off of the subnet that the traffic being advertised should be coming from. Because what if you don't? Well, the simple answer to that question is, if you don't source it off the right subnet, it's going to come out of the interface IP address that the routing table chooses as the egress interface. So if you don't change the source IP, that's why. So, for example, if I was to pull out my pen tool here and draw this out, if you take, let me switch over to black since it'll be easier to see. You have R1, you have R2, and then you have R3. If these guys are all connected, so you got 1.2 and you got 2.3, and you've got, loopback 0 here is 1.1.1.1, and you've got 2.2.2.2, and you've got 3.3.3.3. Well, here's the thing. If I've got NAT enabled on R2, for example, and I want to do a situation where I'm natting so that R2 will allow 1.1.1.1 to go through R2 to reach R3's 3.3.3.3, but because this would be a LAN segment because it's attached to a router, so this would be a connected subnet, right? Or a what does OSPF refer to it as? A stub, where this would be considered transit, right? So why wouldn't you want a transit subnet to be reachable from to go out to the internet? Well, simple. Why would you ever source something from the egress off a transit link that's connecting R1 to R2, right? You would never do that. So what you would do is you would create your access list to match on 1111, and then you would create your NAT entry to call that access list. So traffic, if you just pinged 3.3.3.3, you would get ... Why? Well, because the NAT ACL is only configured to take traffic from 1111. Well, if I was to do the same ping, 3.3.3.3 from source 1.1.1, one of these days I'll get it right. You're going to get what? Well, the first one will probably just be that, but then you'll get 5 exclamation points back, or 4, assuming that ARP is already resolved. Let's assume ARP is already resolved. What's the difference? Well, the one is you sourced it correctly. Is this the only example? No, it's not. There are other cases where if I am doing any type of routing from one site to another and my routing table has been drastically reduced, that is why you would do something like that, where especially when you're doing BGP and you're advertising routes, and if the full BGP, especially with a lot of eBGP, and you're doing next hop self for route propagation, then these are cases where you would have to source traffic appropriately in order for the reachability to be there. But the bottom line is, if you don't source it, it's going to choose the physical port address, and if this particular IP address is not reachable through everywhere in the network, you're never going to get the traffic back. So what I would do, if you're like, this still doesn't make a lot of sense, that's fine. What I would do is I would lab up BGP, a lot of eBGP specifically. And then what I would do is set up a lab like this. Something like this. And then you would connect these guys together like this. And then what I want you to do is you're going to take, let's say this is one autonomous system, and this is another autonomous system, and then this is another set of autonomous systems down here. Whoops, what did that? And what you're going to do is, this will be iBGP, right? You'll do a, and then you'll do iBGP here, all point-to-point connections. You can do a full mesh if you want. So what I want you to do then is then take R7, create a loopback on it, give it an IP address, same thing with R6, and without advertising any of the transit links into BGP, just simply do your BGP peerings. That's it. Set up eBGP between your ASs, do your iBGP peering so that everybody knows how to reach everybody else, and then just advertise these /32s into BGP and try to ping 6666 from 7 and vice versa, but don't source it. And you're going to get a lot of this back. Right? You're going to get a lot of dots. And then change it so that you can reach it. And you're going to have to do like next hop self here, and next hop self here, and so on and so forth. So anywhere you've got where there's reachability, and for the for sake of argument, we'll do R8 over here, and next hop self here. And by doing that, and then advertise 8888 or whatever. Do that, but don't source it from the local subnet, and see exactly how that propagates. I'm pretty confident that you're going to be like, I don't know what's the point. I'm pretty sure you're going to be changing your tune very, very quickly. But my point here is challenge. Anytime you have anything in your brain that you want to challenge, or it doesn't make sense, challenge it. Like, okay, why does it work that way? Always take that, always ask, why does it do that? Why does it do that? And then, see this guy right here? Click on it and go, why? And then whatever the question is into Google for BGP or whatever it is you're doing. I have no problem with you dropping a question here in the comments. Happy to try to answer your questions, but that's the reason for those specifics. So, and I remember when you said petition for longer AMAs. You're getting half an hour a day out of me. So how much more do you want? Anyway, so hopefully that'll answer that one. All right, moving on. So the next one is redistribution should be avoided on PE and heavily loaded ISP routers as it uses a huge amount of resources. True or false? Depends on the design. Maybe. It depends on what's going on. If you need to redistribute for some reason, redistribute for whatever reason you need to. If you don't, in my opinion, redistribution should be only used when you absolutely need to use it, or in times of scale. So an example of that would be this. Large-scale WAN. This is the one time that I'm okay with you redistributing a lot into BGP or whatever the protocol is. Get my mouse out of the way here. So let's say, for example, you have a edge 1, you have edge 2, and then you have, say, spoke 1, spoke 2, spoke 3, and then spoke N. Could be spoke 73 for all we care. We really don't care what it is. And then you have some sort of connectivity. Let's just say that this is all DMBPN for the sake of argument. So we're going to put in here cloud 1. Everybody connects to the cloud just like so. Now here's the thing. I'm a big proponent on, especially when you're talking about large-scale design, when you've got lots and lots of spokes. There is no number per se, but if you've got less than, say, 50 sites on your WAN, I'm a big proponent of EIGRP, especially if we're talking DMBPN. So anything above 50, I'm like, well, that'll work, but, you know, in my opinion, if you're around 50, that's supposed to be around 50, EIGRP is fine. If you're, you know, I'm going to assume this is a greater than sign. If you're above 50, and depending on your routing design, I would say iBGP would be a good thing to probably around a /24, 200-ish. And then if you're above that, eBGP makes way more sense. And then you can do, for each site you have, you can do a separate private autonomous system number. And if you're, you know, because that'll give you 1,000 sites, because there's 1,000 private ASNs. And if it's bigger than that, which is fine, it can be, I would definitely say that you can go to a 4-byte autonomous system, and you get like 2 billion autonomous systems. So as time goes on. So the reason why I say it like this is this. I am a huge proponent of BGP over the WAN anytime I get the opportunity to do so. Here's the thing. Whenever that is going on, you're going to be doing, and let's say for the sake of argument, you're going to be doing BGP over your WAN. So we're going to pretend like EIGRP isn't part of the equation. So the only time that I would be okay with redistribution is you're going to do some sort of IGP here. So you're going to use IGP here, and you're going to use IGP down here, but you're going to use BGP between here and here. Right, so this will be BGP. Well, what's going to happen? You're going to need to redistribute. So, or you can do network statements. You can go in here and you can add network statements in here for propagation if you want. Advertisement is kind of irrelevant. Well, I shouldn't say how you advertise is irrelevant, but it still needs to be advertised. So, as long as you can get the routes to the edge, that's fine. You can either use BGP network statements to advertise them into BGP, or you can use redistribution. I'm a proponent of redistribution, especially on large-scale designs. So redistribute between BGP, EIGRP, and EIGRP and BGP. So it's going to be mutual. So you would do BGP, and you would do EIGRP, and you would do mutual redistribution between the two. And then you would add in here like a prefix list to match on the subnets that you're going to allow. And then you're going to call that prefix list from a route map, which is going to allow you to control what routes get redistributed. And you can always tag them so that, you know, if a route gets learned in this way, route feedback doesn't come back in, and you accidentally propagate the same route back out. It can happen. So there's some things to take into consideration when you're talking about that. So that's what I would do. That, to me, is the only time redistribution is necessary, unless you are dealing with a scenario where you've got MPLS VPN, and you have your provider edge, and you're doing IGP or static routing inside the VRF. Instead of using BGP, this is the only other time you would ever need it. So unless you have a requirement where you need to bring in routing from one protocol to the other on your edge, that is the only time redistribution, in my opinion, should ever be used. That's how I see it, and it minimizes the complexity of your routing design. Because if you don't know this already, routing designs can get pretty crazy pretty quickly. So hopefully that answers that question. I would say it depends on the design. So as someone that architects a lot of networks, I'm not a die on this hill kind of person because of what it is. Incorrect static routing is the #1. So incorrect static routing is the #1 reason for layer 3 loops. True or false? I don't know where the world you live in, but I can tell you right now, static routing is only one of the major reasons. I've seen static routes. I've seen you can inject a static route and then it can cause a loop. But that's an easy one to fix because you can take a look at the routing table and see it. I'd say it's one of many causes. Redistribution, route feedback, improper route feedback, administrative distance issues. Let me think here. What else is out there? I mean, I've seen EIGRP to BGP. I've seen OSPF to BGP. I've seen OSPF to EIGRP. I mean, it's... I personally think that identifying a loop is easy because it'll easily chew up all 30 hops of your trace route, unless you set your trace route hop count higher. But if you're dealing with networking, you're going to see some stuff that just, it's like, who the hell thought that was a good idea? Well, people put things into play to get stuff done and to get a solution to work. You know, best practice is only best practice if it, you know, you're following a validated design and the customer doesn't have some sort of other thing going on that you don't know about. So I'd say false. It can be a reason, but not the '1 reason. Most annoying protocol ever for you. Can't say I have a protocol that I hate, that annoying. Okay, so the annoying thing that trying to think if there's I can't think of a. So there is, but it's because it's annoying when you don't know it. I think that's probably the best way to put it. Was BGP to OSPF redistribution. And where's it? OSPF to BGP. I forget which one it is. It always hangs me up. But it's one or the other. I think it's BGP to OSPF. It's match internal external. So whichever way it's going, I can't remember off the top of my head. But so it's been so long. But I do remember a scenario where I had to do, there's OSPF to BGP, and I had to, like, I was in the middle of a change window, and I wasn't 100% sure on what all I needed to filter out, because this customer environment was extremely complicated, and funny enough, the customer had actually fired their last partner that they worked with because the engineer that helped them build it out had basically everything that that engineer had suggested to them as a good idea, and the design that they suggested and moving forward with it, this engineer was working towards their CCIE, and they basically wanted to make the environment like a job security type thing, where make it so complicated, but because they have to use us or use me or whatever the case might have been. And that engineer said that to them one day in a call, and with like a director or something. I don't remember the specifics, it's been so long. But long story short, that customer had a good working relationship with the company I was working for at the time, and for some other things, and asked that person to have an assessment done, like a high level assessment. And so there were 2 or 3 of us. I was brought in for all the routing, and I took a look at it, and I was just like, wow, this is a mess. And there was redistribution everywhere. It got really complicated. There's some things that were in place that just didn't make any sense. So I was like, what is going on here? So long story short, it's when you end up walking into environments that are either just poorly managed or poorly designed, or I'm not exactly sure the right term to throw at it, but you get those scenarios where you walk into stuff and you're like, wow, this is just, what were they thinking? You know, it's just like, yeah. Most layer 2 protocol or feature you hate. I'm kind of not a big fan of spanning tree, but I'm not a big fan of VTP. I think VTP is stupid. So yeah, there's that. Most layer 3 protocol feature or feature you hate. Layer 3 protocol. RIP version 1. Most annoying ISP protocol or feature you hate. Well, that'd be BGP. MPLS, segment routing. That's the thing, I really don't hate anything. Well, I'm actually gonna flip this one over to and layer 3 that doesn't make sense would be Lisp. Lisp in some cases doesn't make sense to me. You know, what the purpose of it behind it, even though I've read the documentation for it and and I understand how it works, I've labbed it up, it just doesn't make any sense to me. So as a network engineer, you said you studied route switch, load balancers, firewall, servers, SD-WAN, virtualization, and cloud data center security. May you advise us with the path of what should be done first sequentially. If I remember correctly, you said RNS first, then virtualization, then DC. Yeah, I mean, here, so if you were to put them in an order that makes sense, routing and switching, then wireless, then firewalls, then security, or not security, data center, because yeah, data center first, then virtualization, and then servers. Because you gotta, like, I'm an infrastructure engineer, so I'm always thinking bottom up. So I always look at routing and switching, and then virtualization. Virtualization sits on top of the data center, right? It's an abstraction. So when I think server, I don't think physical hardware. I think Windows server, Linux server, Apache, whatever it might be. That's where my brain goes. When you talk about virtualization, data center is a collection of capabilities, servers, virtualization, all that type of stuff. SD-WAN is going to fall in that, and stuff like that. But I would definitely start off. You missed wireless. Load balancers are in there, but they're kind of specialized because they're handling user requests for access to stuff. So that's how I would go about doing it. So routing and switching, then wireless, because you're talking end users, and then load balancers are going to help. Kind of load balancers and firewalls, but load balancers are going to come technically after firewalls. I almost dropped my pen. So yeah, that's how I would go about it. And then virtualization, because you have to understand data center virtualization before you can deploy Windows servers. At least that's the way I look at it. Oh boy. So if I have two eBGP neighbors over a static route using loopback addresses and they are right next to each other, one, why do I have to use the eBGP multi-hop command? First, or aren't the first hop is each other, or are the loopbacks and the physical ports interfaces counted as hops? Two, why do I have to create a static route for the loopbacks? I mean, doesn't BGP act as an overlay in a way over the physical fiber static route? Oh boy, this is all right. It sounds to me like you, and no offense, sounds to me like you need to go back to the basics of BGP. That's what some fundamental stuff is missing. So let's, and I mean that with all due respect. I'm not picking on you. I'm really not. So of course I had to bust this out. So let's first define an autonomous system, because the moment, and there's two of them, because you mentioned eBGP. Okay, so eBGP means there's two ASNs, right? We're going to have AS1, AS1, and you're going to have AS2. So it doesn't matter R1, R10, R75, doesn't matter here. They're connected to each other, right? And it says you have two eBGP neighbors over a static route using the loopback addresses, and they are right next to each other. Let's answer your first question. So, okay, first of all, you're doing eBGP multi-hop, first and foremost. So, what is the first rule of eBGP? Especially, we're Cisco shop, I'm assuming, right? So what's the first rule of eBGP? Directly connected neighbors. Which means you have to be on what? The same subnet. Okay, so you have to be on the same subnet. So you have to do what in order to get this reachability? So let's talk through this. I want to do eBGP with you and me. So what are the most basic breakdowns for this to work? So I have loopback 0 here, and I have loopback 0 here. Out of the gate, without doing anything other than IP addressing this with, say, 10.1.2.0/30. So this is .1, this is .2. I don't have anything else configured except that. And BGP. I've got router BGP1 and I have router BGP2. How do I get loopback 0 to talk to loopback 0? If I wanted to ping from this guy to this guy, is it going to work without any additional configuration other than what I've laid out here? No. Why not? Well, because this guy right here is acting as a stub network. So just assume that this is a network attached to it. So in my routing table, let's do a routing table lookup. If I do a show IP route for 2, going back to what we talked about a little bit ago, and 1, 1, 1, 1. If I look at my routing table on R1 or on AS1, am I going to see 2, 2, 2, 2 in the routing table? No, I'm not. Why? Because it's not being advertised, right? So AS1 has to have a way of getting 2, 2, 2, 2, 2. How does it do that? Static route's one way of doing that. So if I have a static route here, 2, 2, 2, 2, 2, can I ping then? I actually can. Because I'll be coming from this IP address, AS2 is directly connected to that, he'll know how to reach it. So 2222 will actually respond as long as it's coming from the connected subnet. Now, let's take it a step further. Let's go back to your original question that you asked about why can't the physical port, which you put in all bold letters, which I thought was actually kind of humorous. So this is a classic example. It has nothing to do with NAT. So now let's take this a step further. If AS2 did a show IP route of 1.1.1.1, is it going to be able to reach it? No. So how do I fix that? We're going to do a static route to 1.1.1 here. And this guy's going to go this way. So now, will they be able to reach each other? They will. And you can source it as well. So if you do a source, so if you ping 2222, so if I do a ping 2.2.2.2, sourcing from 1.1.1.1, I should be able to ping it. I should be able to go back and forth. That's the very minimum that you need in order for this to work. Okay, what's the next step? I know you're not able to answer this, but I'm legit giving you a minute to think, okay, what's the next step? But you have your neighbor command, right? And you want to do loopback to loopback. So we'll say the neighbor command on this side would be 2.2.2.2. Remote AS, we'll just put it in here, remote AS of 2. And the same thing over here is going to be neighbor 1.1. Remote AS 1. Now, is the BGP peering going to form? No, it will never. You could be here until the day you die. BGP is just going to sit there and circle the drain until you do an additional step. What is that additional step? So now that we've established that, well, actually I got a little distracted. So we have this configuration in place. So what's the next step? Well, next is going to be what? We're going to say update source is going to be loopback 0 on both sides. And I am shorthanding this on purpose. So if it looks a little funny, that's why. Okay, what about next? Still not going to form. What do we got to do? Well, that's where the eBGP multi-hop comes into play. So and then we're going to say, we can do a minimum of 2 because we're 2 hops away. So we'll do the same thing. EMH is 2. So with that being said, then the peering will form. So no, BGP does not act as an overlay in a way over the physical fiber static route. In order for BGP is just a reachability protocol, right? So as long as you understand that, then that's the key thing. So do you need eBGP multi-hop? Well, theoretically, no. You could do what they refer to as disable connected check, and that would theoretically get the job done. Now, I very rarely ever use this command, but it's checking to see if you're on the same subnet. Now, I have heard people argue that eBGP multi-hop is not necessary if you turn off disable connected check, but at the end of the day, it's one of those things where I can't really think of a reason why, other than this, you would need it. So why do I have to use the eBGP multi-hop command? Aren't the first hop each other? Or are the loopback and physical port interfaces counted as hops? No, they're not counted as hops. 8 autonomous system numbers are counted as hops. And this is why I said, I think, straight up, I think you need to go back to your basic BGP and do a reassessment of your base knowledge. Because this is like stuff that you would learn just beyond your CCNA, maybe the beginning of your CCNP, when you're starting to dig into how BGP operates. And based off of some of your other questions that you've brought up, why you need BGP here and why does BGP work that way, there's some core fundamental pieces to BGP that I think you need to go back over and learn. Because not saying that you don't understand what's going on, but just the way you word some of the questions tells me that there's some fundamentals that are missing. So if you were to do it this way, then your BGP peering would form, and then you'd be able to exchange routes with each other. That's how that would come into play. So, and I drew it out exactly how I've done it before. So, is this hard to do? No, not at all. But BGP is between autonomous systems. So the only time I've ever seen this done is whenever I've got 2 physical interfaces connected between the routers for load balancing purposes. Because then the loopbacks are routed, and then in the routing table, you're going to have 2 ways to get there. So you would actually have 2 static routes. You could use IGP in order to get there. You could even use directly connected BGP to use that. Matter of fact, especially when you get into things like VXLAN, EVPN, this is a very common thing to do, especially with the DCI when you're doing multi-site. Very, very common thing to do is, or when you get into, and it's probably a little ahead of where you're at, enter AS option C is how you would do that. You would do, your route reflectors would form an eBGP multi-hop peering via VPN v4. That's another thing. But again, there's some fundamental pieces to your BGP that I think are missing, and you need to go. And anybody that's questioning why this doesn't work, I think we need to go through those details. So that's essentially where I think you need to go with that. So hopefully that answers your question. If not, I'd be happy to dive into it more. Please don't take anything that I'm saying as a personal attack on you, because I'm not. I'm answering your question straight up and identifying just based on the way you ask the questions, there's some things that are missing. And whether you need to lab them up or whatever the case might be. And I'm going to handle this one real quick since we're right here. And we're talking about eBGP. So I wonder, does eBGP ever act as a rendezvous point, well, technically you spelled rendezvous point. I think you were trying to hash it together. Route reflector. So I'm going to assume you're talking multicast. So, because you're mentioning rendezvous point. And by the way, rendezvous is actually spelled R-E-N-D-E-Z-S-O-U-S. That's rendezvous. Well, no, take vu. That's rendezvous. Rendezvous point. What is a rendezvous point? An RP for short. An RP is what joins your source tree, your multicast sources, to your your PIM sparse mode shared tree receivers. Because in PIM sparse mode, the multicast traffic just isn't sent. PIM dense mode it is. You don't need an RP in PIM dense mode because everything's automatically sent anyway. Multicast traffic is sent to your receivers whether they need it or not. PIM sparse mode, your receivers have to ask for it, and then multicast flows are built from the RP. You know, they both join at the RP, and then the initial flow goes through the RP, regardless if it's in the data plane or not. And then once that's been accomplished, then there's the shortest path tree switchover. By default, it's turned on, so it will automatically fail over this. As soon as the first packet goes through, it'll automatically switch over to the shortest path tree. So if you have your source and you have your first hop router, then you have your, we'll say mid hop, you have your RP, then you have your last hop going down to your receiver. The source is going to send traffic out because he's going to start sending traffic whether you want him to or not. And he's going to send this to the first hop router. The first hop router will send a register source message to the RP, and that's what's going to get you your S comma G. So your S comma G is going to show up here, and that's what's going to show up in your show IPM route table. The receiver is going to send a message, what's called an IGMP report message to the last hop router because it's the end of the multicast flow, and that's going to be converted to a PIM join, which will be sent to the RP. And this is what's going to be your S or your star comma G. In other words, you have a receiver signaling for multicast traffic from a particular multicast group. Well, the RP is going to join these two together. And what will end up happening is as soon as the multicast flow starts, and if you want to test this out, you can literally ping on the source, say 224.1.1.1. That'll work. If you ping that address, you should get, if this guy here is 10.1.2.3, you should get a reply from 10.1.2.3 back. That means multicast traffic is flowing. Now the RP is in the data path between all these guys. What will end up happening is the RP in this particular case is set up here, but the moment you go from your source tree to your shared tree, as soon as the first flow of multicast goes to the RP, the SPT, the shortest path tree bit is flagged, and then the traffic goes directly this way. Now that's a high-level overview of how multicast traffic flows work. I wonder, does eBGP ever act as a rendezvous point route reflector? I don't exactly know what you mean by that, but if I had to guess, the question here is that you have, say, R1, then you have R2. This is an AS1, this is an AS2. They form an eBGP peering between each other. This guy's also acting as a route reflector for R3 and R4. And R4. So he's got, this is iBGP, and it's route reflected. So R3 and R4 learn about 2.2.2.2 because R2 advertises that over R1, R1 reflects that down. Can he be a rendezvous point as well? He can be a rendezvous point as well. That's supposed to be RP. And then we have RP. He can be a route reflector for that. He could also be a rendezvous point for PIM if he wants to be. So that would work. It can. But it's one of those things where, is it unusual? It can be. I mean, it depends on the design. So would I do it? Sure, if I need to. At the end of the day, it's just whatever I need to do to get the job done. That's what really what it boils down to. So hopefully that answers your questions. I know this is a little bit of a longer AMA, but at the end of the day, I'm here to try to answer your guys' questions and go from there. So if you guys have questions, comments, concerns, feedback, drop that in the comment section below. I have yet to put the links in for the live streams for Wednesday and Friday, but I'll get those out here shortly. And then once I do, you guys will be in good shape. If you guys have any questions, the links are the $10 a month for the membership will be in the link, plus the sample workbook and the real workbook, and we'll go from there. I'm going to clear the screen, minimize that. So until next time, guys, thanks so much for stopping by, and I'll catch all of you guys in the next one.